Now we will start the programming part, that is we are starting with chapter number 6. So chapter number 6 to chapter number 12 are related to C++ programming. For exam point of view as well as theory and practical concern, these lessons are very important, right? So we have to concentrate on this more. The chapter number 6 title is the basic concepts of OOP. Basic concepts of OOP. OOP stands for Object Oriented Programming. OOP stands for Object Oriented Programming. So the Object Oriented Programming is a model that represents concepts as objects that have data fields and associated procedures known as methods. It means this object-oriented programming is basically concentrating on the objects. The object-oriented programming is a combination of two things, that is the data fields and the associated methods. The object-oriented programming emphasizes on data. It means the importance is given for data. The ideology here is to unite both data and functions that operate on that data into a single unit called object. The main idea behind this object-oriented programming is that it combines both data and functions that operate on that data into a single unit called as object. As I said in the first sentence, that this object-oriented programming is mainly representing the objects. It means, what is the object? Object is nothing but it is the combination of both the data and the functions associated with it. And one more definition for the object is, the object is an entity with some characteristics and behavior. What is an object? Object is an entity with some characteristics and behavior. This is about the object you learned, right? What is object we know now. Then another important concept with respect to object-oriented programming is a class. One more what we get is a class. The second year C++ programming starts with a class. It is one more concept we are studying here. The another important concept of object-oriented programming is a class. The class serves as a plan or a blueprint that specifies what data and what functions should be included in the objects of that class. It means the class is nothing but a blueprint. What are all the objects can be added? What are all the data members can be used and the functions can be used for that particular object can be described by a special characteristics called as class. So after knowing the two things from this lesson, that is in the introduction part, what we learned is, one is object, second one is a class. What is an object? The object is an entity with some characteristics and behavior. Then what is a class? Class is a blueprint that specifies what data and what functions should be included in the objects of that class. Right? Some more definition will learn concerned to this in the next lessons, especially concerned to a class. Now, after knowing the two terms, that is object and class, now we move on to the next heading called as the major characteristics of OOP. The major characteristics of OOP. The major characteristics of OOP contains total 9 characteristics. Total we have 9 characteristics. That is, first one is called as the objects. Second one is classes. Third one is data abstraction. And fourth one is data encapsulation. Fifth one, inheritance. Sixth one, overloading. Seventh one, polymorphism. Eighth one, dynamic binding. And the last ninth one is message passing. These are the 9 characteristics of OOPs. If you complete these 9 characteristics, then this chapter ends. In this chapter, we are going to study the characteristics, advantages, and the applications of OOPs. And then the first part is the characteristics. Total we have 9 characteristics. If you remember these in an order, it is easy to define, right? Because based on this particular heading, normally you will get a 2 marks question. Sometimes you may get one yesterday question for 5 marks. Either they may ask 2 definitions or briefly explain about any one of these characteristics or explain the characteristics of OOPs. That is a yesterday questions what you will get, right? So now we move on to the first one. That is, we'll start with the first thing, that is, wait, the objects. What is an object? The objects are, right? Objects are the basic building blocks for designing programs. What are objects? One more definition we are learning here. Objects are the basic building blocks for designing programs. An object may be a person, place, or a table of data. Examples are, it may be a person, or it may be a place, or a collection of data in the form of table is nothing but an object. This one definition we learned. Then one more. An object is a collection of data members and associated member functions. An object is a collection of data members and associated member functions. Each function is identified by a unique name. This is the third point. Each function is identified by a unique name. Next point. Every object must be a member of a particular class. Every object must be a member of a particular class. Then the examples are apple, mango are the objects of a class fruit. So consent to objects, what we are learning is the first thing, that is objects are the basic building blocks for designing programs. Without an object, we cannot write a program. That we are stating here. This is the basic things we need to write the program. It means our programs will start with a class. The next one, second point is example you have stated, that is example. In the example, it may be a person, place, or a group of data in the form of tables. Then after that, once again you define one more definition, that is an object is a collection of data members and associated member functions. What is said in the previous case in the introduction part? An object is the collection of both data members and member functions into a single unit called as object. And you all know that in our day-to-day life also, we are using different functions with different names. By knowing the name of the function only, we can understand what is the things that will happen in that particular function. It may be a birthday function. It may be a welcome function in the colleges. Right? So by seeing that, we come to know that what are the activities will be taking place in the particular functions. Like that, here also, each function is identified by a unique name. It means every function is having their unique names. Then every object must be a member of a particular class. Whatever the object we are creating, that should be the member of a particular class. Always you have to create an object consent to a particular class. That's why in the example you stated that if you take a class name as a fruit, means only you have to make a list of fruit names. That's why I stated that apples, mangoes, bananas, right? These are the objects of a class fruit. Then if you observe the thing here, the right side here, the object we have taken student. The object name what you have taken is, the object you have taken it as student. You take an object as a student, then related to this object, you have to create the data members and member functions. How do we know that? Object is a combination of both data members and member functions that we are showing in this particular diagrammatic representation, right? So in this, if you take an object as a student, then the member of the data or data members must be related to this object only. That is a name and roll number. Name, that is student name, and student roll number. These are the data members of the object student. Then related to that, the member functions are get data and display. Get data and display. These are the two member functions we have declared for the object student. It means this object student has two data members, that is name and roll number, and two member functions, that is get data and display. Right? This is very important. The characteristics of OOPs are very important. If you understand this, it is easy for you to design the programs. Right? Okay. So after knowing the first characteristics in this lesson, that is objects, now we move on to the next one, that is classes. Right? We'll go with a class. Second, so a class is a way of grouping objects having similar characteristics. Class is a way of grouping objects having similar characteristics. First point. Second point, once a class is defined, any number of objects of that class are created. Example, sun, moon are members of a class solar system. Then one more point we have added here. Classes are user-defined data types. Classes are user-defined data types. Class can hold both data and functions into a single unit. Class can hold both data and functions into a single unit. Right? If you take an example related to this class, so in the code also we are using a term called as class. PUC first year class, PUC second year class, PUC second year CS class, BM class, stat class, like that. What it represents? If you take an example of PUC second year CS class, then you can relate that here. The first sentence. What is PUC second year CS class? In that class, the students, those who have taken CS as one of the subject, they will be joined for second year CS class. CS class belongs to CS students. It means all the students of that class have the same characteristic because they all belongs to CS subject. Is it clear? The first sentence, that is, a class is a way of grouping objects. Each and every student is an object here. A class is a way of grouping objects having similar characteristics. It means each and every student is an object. All the students are grouped into a single class called as PUC second year CS. It means all the objects, all the students have the same characteristics, that is, all the students are taken CS as one of the subject. That's why it becomes 2 CS class. This is first sentence. A class is a way of grouping objects having similar characteristics. Then second one. Once a class is defined, any number of objects of that class are created. Right? In certain extent, you can use this sentence also for the same class example. Once there is a PUC second year class, right? Any number of students can be joined into that. Up to certain extent, that is. In reality, it may vary, but for according to this sentence, you can say that once there is a P2 CS class is there, means any number of students can be joined for that particular class. That sentence is given as once a class is defined, any number of objects of that class are created. Then examples, the solar system we are taking it as a class. In that, sun, moon are the members. Then one more definition is given. Total we are defining the class in 4 ways. In the first, what you stated is class is a blueprint. Right? Class is a plan that is going to describe what are the objects it has. Right? After that, what you are defining? Class is a way of grouping objects having similar characteristics. Second definition. And one more definition, what you are given? Classes are user-defined data types. Third definition. And the fourth definition, you can define that just like object, a class can also hold both data members and member functions into a single unit called as class. It means class we are defining with a 4 definition. In that, at least you can remember 2 definitions thoroughly. Right? At least 2. Why I am stating this? Because this chapter is very important for programming concern. Even in the practical, the Viva questions based on this lesson. define all these characteristics, they may ask from this 1 or 2 questions. Right? That's why each and every characteristics what you are studying in this lesson are very important for concept based as well as exam point of view to get the marks. Right? So give more concentration for this chapter. So what are the statements you have learned here? Sentences. The same thing again, picture you are representing here. See here. Here we are showing that again class is a combination of both functions and datas. N number of functions, that is function 1, function 2, dash dash up to function ends. Right? N number of functions. Each function is having their unique names. Then we have data members, data 1 to data n. N number of functions, n number of data can be used in a class. Then, after knowing the second characteristics, now we move on to the third one. Right? Third characteristics. That is data abstraction. Data abstraction. The data abstraction permits the user to use an object without knowing its internal working. Data abstraction permits the user to use an object without knowing its internal working. One definition, and one more definition is that is the data abstraction refers to the process of representing essential features without including background details or explanations. They're defined in 2 ways. 2 definitions are given concerned to data abstraction. Then example, we do not exactly know how the fan functions internally, but all of us know how to use a fan. See here, to take an example of that fan, everyone knows how to use a fan. When you switch on, you will get the air from a fan. It means we all know that how to use a fan, but exactly how it works we don't know. The working of fan we don't know, but how to use it we all know that, right? It means to explain data abstraction, again I'll repeat the second definition, that is it refers to the process of representing essential features without including background details or explanations. Then fourth one, data encapsulation. Data encapsulation. Data encapsulation combines data and functions into a single unit called class. What is data encapsulation? Data encapsulation combines data and functions into a single unit called class. It prevents direct access to data. This is a very important point. It prevents direct access to data. Data can be accessed only through the functions present inside the class. Data can be accessed only through the functions present inside the class. The data cannot be modified by an external non-member functions of a class. It means data encapsulation is providing one of the basic important feature for the program, that is it provides data security. Right? The data encapsulation is providing data security. That's why we have stated that it prevents direct access to data. When the data are available, suppose you take an example of a class. If you write the data members inside the class, then the data members of a class cannot be accessed directly. It means they are secured. Right? This is provided by one of the important characteristics of OOPS called as data encapsulation. That's why I stated clearly that this prevents direct access to data. This should be highlighted. Otherwise, you will miss the marks while writing this. Right? It provides data security. Then, after knowing the data encapsulation, we move on to the next characteristics called as, that is, inheritance. Inheritance. What is inheritance? Inheritance is a mechanism by which one class acquires the properties of another class. Inheritance is a mechanism by which one class gets the properties from another class. A class gets the properties from another class is called as inheritance. For example, if you take two separate classes called as father and son are the two classes, the son gets the properties from a class called as father. Right? It means son is inherited class. Son gets the properties. Instead of properties, to understand the concept, we can say that the characteristics, right, are the characters. The characters of what we are getting from the parents are nothing but inheritance. Right? The object of one class acquires the properties of another class through inheritance characteristics. In these two classes, the father class is called as base class and the son class is called as derived class. It means two more definition we are using here. One is called as base class and second one is called as derived class. Then definition. Define base class. The existence class is called base class. What is base class? The existence class is called base class. Then next, what is derived class? A new class is called as derived class. A new class is called as derived class. In the example, the class father is base class and the class son is a derived class. Right? So again, this particular characteristic is also very important because based on this, you are studying complete one lesson in future. Then we move on to the next characteristics called as overloading. Overloading. The overloading allows objects to have different meanings depending upon context. What it does, the overloading allows the objects to have different meanings depending upon context. In this overloading, there are again two types. One is called as operator overloading and the second one is called as function overloading. Function overloading. Operator overloading, function overloading. These are the two types of overloading you will get. Then again, first one, operator overloading. When an existing operator operates on a new data type called as operator overloading. When an existing operator operates on a new data type is called as operator overloading. And the second one is function overloading. The function overloading means two or more functions have the same name but differ in number of arguments or arguments data types. First one, if you consider the operator overloading, you take an example of operator. As you have studied in your first year, a chapter called operator. What is an operator? Operators are the tools used to perform some operations. Operators are the symbols used to manipulate data. This definition you studied in your first year, right? Then if you remember different types of operators you have studied, in that I will take the simplest one, that is plus. What the plus sign does? Commonly in our mind, what we will get? It performs addition operation. Sum. Then that is one operation, fine. If I write like this, if I write plus 5, can you add now? Plus 5. Same symbol I use it, plus 5. In our mind, in the first case it performs addition operation. But in my example I have taken only one operand, that is 5. Right? For that I added plus. Plus 5 means you cannot add with a single operand. It means this indicates the given number is a positive integer. The given number is a positive integer. It means the same operator is behaving differently. Depends on the context. Clear? The plus operator behaves differently. Sometimes it indicates the number type, whether it is a positive integer or negative integer. And sometimes if you use more than one operand, if the operator is in between the two operands, then you may go for sum of that two operands. It means it performs both the operations. That's why you can say that operator is overloading. Then function overloading. In this case also the same thing. In a single program, two or more functions may have the same name. Two or more functions may have the same name. But this is very important. Because I stated each and every function is having a unique name in the class. But now what we are studying is two or more functions may have the same name. But is very important. But they should differ in either the number of arguments or their data types. Example, if I take addition, they use a different functions. What is written in chapter number 13? So chapter number 12 and 13 of your first year, right? So if I take an addition function, in that addition, open parenthesis, int a comma int b, close parenthesis, semicolon. It means I declared a function called as addition with two arguments. Both the arguments are of the type integers. Fine. Now what I'll do is one more example function I'll write, that is its name is also addition. But that contains, instead of int a int b, I'll change the data types. That is, I'll go with open parenthesis, float a comma float b, close parenthesis, semicolon. Now if you observe these two functions declarations, even though the name of the functions are same, both are addition only, but that's why I stated but is very important. But they should differ in number of arguments. No, that is also failing here. In the first function also there are two arguments, that is int a and b. In the second function also there are only two arguments, that is a and b only. But second, last part is important here. Their data types are different. In the first function we use integers, whereas in the second functions we use floats. That's why this is a valid example for function overloading. I hope you understood this overloading concept, right? So it means in the today's class, we have started with one of the important lesson called as object-oriented programming. In that, we have defined first what is object, then what is class. After that, we have started with the important characteristics of object-oriented programming. In that, we have completed what is an object, what is a class, then what is data abstraction, what is data encapsulation, inheritance, and last overloading. 6 characteristics we have completed. In the exam, you may get briefly explain any one of these characteristics for 2 marks questions. If you find any difficulty concerned to these, don't hesitate to post your queries in the webinars. Thank you.
It's been said great.